And welcome back. Let's go ahead now and create our own linked list because we've up to this point used kind of a pre-made example that we've kind of been working through to kind of learn. But as I mentioned back in the very beginning, there is actually a linked list class that exists within the java.util that we can actually use now that we have a great understanding of all the different pieces that have a linked list work. So we're going to import in that linked list class, which is pretty easy. We just say import java.util.linkedList. And then once we've done that, we can actually then go create our linked list class. Now, linked list is a generic type. So just like array list, we can go ahead and create whatever type we want to do. So remember with array list, for example, I could specify that it was a string, it was a double, etc. Let's go ahead and use this one as a string, and that's going to give us a good foundation here. So we're going to go ahead, again, specify, let's say this is a string. And once we've done that, we can, of course, can specify what we want that linked list to be. So we'll just make this a new linked list object. And just like that, we have our linked list. Again, remember, very similar to how we set up an array list because it's generic type. And then from here, we can start using those linked list methods to actually add things into this list. So let's go ahead and first add a couple items to this. So let's add this to the list. And so we can just do list dot, and you notice we get a list of functions that pop up right here right away. So I'm going to go use just the add method, and you notice it just takes in a string, and we can add in whatever strings we want this to be. So let's just go ahead and just say first. And I'll just leave it as first. That sounds like a good one for demonstration. And let's do list.add. And now this will be, of course, let's say second. And more cursor moved to me. There we go. List.add will do now third. Now, if you recall how this linked list works, is that these, of course, are going to, if we were to print this out, it's going to print out not first, second, third, but to print out third, second, one, because remember, it's always adding to the start of our list. And so if we do list dot, and you can see again, we got a bunch of different things in here. We have clear, we have clone, we have contains. So these again are all different methods that we can do. We have we can pop items off, we can peek at them. So these are all, of course, getting those elements. So for example, peek, if you look at what it does, it's going to retrieve but does not remove the first element of this list. So for example, if I wanted to peek at that list, what does that mean? So let's just say I go ahead and put this in a system.out.println. And then I go ahead and run this. We should expect it to return whatever the first value is. So we're saying first, okay, so it's getting the head of that list. And again, this is something that we have to think about. How does this get added? So this, of course, it says it returned the first item here, which is first. All right, so we have a great item here. So this, again, our peek. What else do we have here in our list? So we can see if it contains something. What if we wanted to actually, though, remove something from our list? Well, we can do that very easy. Let's say we want to remove. Well, what are we removing? What value? And if you look at that, we are saying we want to get rid of a certain thing here within that list. Because if you look at how the remove command works, with remove, it is taking in, you can put in a int index here. So if you just do remove, it's just going to remove the head of the list. Whereas if I specify that with a value, I can specify which one I want that off. So that's a great way to do that. Of course, we can also get the size of the list. So of course, if we just do list.size, and if I were to put that inside of a print line statement here, that should tell me the size of this list. So if we run this, we say first and two, which makes sense because we removed an item. So I'm just going to add a comment here, removes the second item. Although this is really not really the second item, because remember this is the second index, really. It's not the zero index. If you want to think of the third index, a good way to put that. And of course, this is just, again, printing out the size of the list. We want to look at a couple other examples here that we can do. You have the option, of course, to print this into an array, which is a pretty nice thing. So if you wanted to put this to an array, then you could use all the different kind of array functions that you might expect to have. You, of course, can sort this, which is a pretty nice thing. So this, of course, allows you to do it. Of course, you have to have the specified comparator operator here. We can set certain things. So if we want to set a specified value within that list, So let's just say I wanted to set at, instead we have this right now being first at this one, let's just say I want to change index 0 from first to, let's say, beginning. All right, that would, of course, then change it. So let me just go ahead and grab this peek command again here. And I rerun this. You'll see that it has now changed the first node to say beginning. So again, pretty cool at how this is working. And again, this is all built right in, so we don't have to go through and necessarily build our own linked list class, because this again all exists within Java. A couple other methods I want to show you real quick here before we kind of play around with it a little bit more is if we look at our pop and push here, pop, if you remember, is going to pop an element off that stack, all right, which is the first element of the list, whereas push is going to insert an element to the front of the stack. All right, so let's just go ahead and pop a first element. And if we're just going to use peek again here to see if that changes anything. If we go ahead and rerun it, you'll see that first, remember, was removed because it was first, which became beginning, which we popped it off that list, which means now when we peek at it, it is now second. So let's just go ahead and see if we can run this, right? We wanted to necessarily print these out. What if I wanted to print out this list here, right? What if I just did a quick while loop, so list dot, let's see, if you wanted to run through that full list, you could do that. But a better way to do this, instead of trying to rely on peek, is remember, we can actually just print this list directly. So if I just go ahead and say system.printline and I say list, it's actually going to print out that as a kind of array of elements here. So we get first, second, third. So it's a great way for us to check to see what the list is. And so if we wanted to, we could use that instead of peek to see what this is, just to see how this list is changing. So I'm just actually going to replace this here with a couple list iterations here, just so we can see how this list is changing now. So let's go ahead and run this. So we got first, second, third. All right, this now, of course, is peeking what's the top of the list, which is first. We of course then remove the second element, which is actually the third element here, because it's the second index. So it's 0, 1, 2. So 2 would be here at third, so that's gone. So now we have first, second. Then we changed the first value to beginning, and then we popped it off, which now it's just second. All right, pretty cool. Again, this is all built right in here, and all I have to do is type in the name of my linked list type. I do dot, and it brings up all these different methods that I can then play around with. And these are all built in. I don't have to go and code these or rely on the various examples that I had previously, because again, this is all built into the class that's within Java. Let's just look at a couple more here real quick. And I want to show you that we have the option to do a couple different things. So for example, if I want to add at the last, so this allows me to pretty much add something to the end of that string. So I'm just going to go ahead and change this to end. And if I go ahead and do an add list end, and I'm going to print out this list again, and I rerun my code, you'll see that we now have a very similar structure to what we had previously. The nice thing is, this again is all handled to us. So if I ever want to put something at the beginning of the list, I can do that. If I want to put something at the end of the list, I can do that as well. Again, this is all built right in, so it gives me a lot of power of what I want to do. We can, of course, there's get methods in here too, so we can get first, get last. So we can, of course, simply just get those values if we want, rather than necessarily peeking and stuff like that. We have options of how we can run with this. You can see we also have the same thing with remove. We can remove first. We can remove first occurrence of. So it's a great way to look to see if something exists within your list before removing it. We of course can remove last or remove last occurrence of. So again, great ways for us to go through and traverse a list to remove certain items that we might want in the list. So if we had, let's say, a list of 10 items and we want to go and remove the last occurrence of, let's say, the word big, all right, just a combination of, like, let's say big, small, and medium, and we want to remove one of those items. That's a way for us to clean that list up. Now, the only other thing that I want to really show you real quick is that we, of course, have in here some methods that we haven't quite talked about as much, which, for example, like is poll. Poll, of course, retrieves and removes the first head of the list. And the nice thing about this, it's like a combination of our peek method and, of course, our remove method because it's going to tell us here's what the item was before it takes it off. But again, this is just some cool things for us to play around with to really kind of get in here. The only thing you might say, well, what's if I want to add something to the middle list? Well, again, remember we have this add index, which again is going to allow us to add something at a specified place. So we had set, which of course allows us to set something, but let's just say I want to add this position 1, so I want to add it between these two, and let's just say I'm going to have this say middle. And if I go ahead and do that, and I run this, is that you can see it's now added to the list. So again, we have a lot of flexibility, a lot of built-in things that we can do. We don't have to rely on simply just the head node for everything. We don't have to rely on simply just the tail of our list. We have a lot of features and functionality here. And with a linked list, just like with an array list, it's very flexible in its size, so we're not tied into a certain size value. Notice I never set a size to my linked list, which gives me flexibility in how I can use these different nodes. Now, one thing I do want to note here, just as a closing, is that if you start looking at this with our analysis for big O, all right, which we previously talked about, is that there are some disadvantages of a linked list over that of an array list. And with a linked list, one of the things to keep in mind is that it's going to be slower than an array list because of how it can access indexes. And it also has more memory overhead because remember, it has to keep track of all the different links that it has to use. So that is one thing to kind of keep in mind if you decide to use a linked list.